Right, good evening, everyone. Today's agenda has a new problem called the secretary problem, which is an interesting problem that I've known about for a little while and wanted to share with you guys today. So, it's a little bit more complicated than the other problems that we've seen, but I shall not be covering the mathematics today. Obviously, I'll do them in another video, but today we shall just look at the problem, look at the solution, and try and code it ourselves, right? So the secretary problem, what is it exactly? So it's so we take the role of an interviewer who needs to hire some people for a new position, and there is only one position, right? And so this interviewer knows how many applicants they have, and so they got to interview people one after the other, but the catch is that they have to choose after every interviewee, so every person they interview, they have to choose whether or not they hire him. So what happens is, so obviously, so you'll have the first guy, and then you're going to choose whether you take him or not. If you do not take him, well, then you can't go back on your decision. So you have to pretty much hire one of the next people that comes, right? So we work on the assumption that the number of people is known. This will not always be the case in real life, but hey, this is maths, not real life. And we also assume that every applicant from 1 to n has an arbitrary order. So obviously there's the best applicant called applicant number n, and then there's the worst applicant, which is applicant number 1, and they can all be arbitrarily sorted. If we had them in the room, we could literally easily see, right, okay, this one's the best, this one next, this one next, this one next, and then one is the worst, right? And and one of the next assumptions is the applicants are interviewed in random order, obviously, otherwise where would the fun be in the game? And yeah, so we want to find this applicant number n, applicant n, and we shall consider it a win every time we do, right? And there are multiple ways to go about doing this. Well, we can literally just go and hire the first guy we see and then not worry about the others. But mathematically, if we want to get the best applicant with the highest probability, then we'll have to think about it a bit. And one of the solutions is this. So it's called the 1/e rule, or 37% rule, or the stopping rule. I'm not sure which one's the proper one, but the reason it's called this is that it will about 37% of the time give the correct applicant as the hired applicant, right? So this is pretty good, actually, considering we don't know anything about the applicants and we have to hire them or reject them on the spot. So how does this work? We choose a number r in the natural numbers, obviously smaller than n. This number has I'll show you in the next video how we compute this number and how this number can be how this number can be optimized to give the best probability, but not in this video. And then what happens is we interview everyone, every candidate up to this number, or until r minus 1, and we will reject all of them, right? So if we have 10 applicants and we pick r to be 4, for example, we shall interview applicants 1, 2, and 3, reject them, and then we shall see from there on. And afterwards, what we do is we decide, so from the 3 first candidates, or the r minus 1 first candidates, we choose the best candidate, right, called candidate m. And then we continue interviewing the next candidates, and what happens is the next time that we get a candidate better than m, we pick him or her, right? So it's this simple. And if we do not find any candidate better than m in the rest of the list, then we don't have a choice. Unfortunately, we are forced to pick the last candidate remaining. And yep, so this is unfortunate, but this is how it works, right? So for example, just to explain it a bit more, if we, for example, if applicant number n is shown first, then we obviously will reject them, and unfortunately we will not find anyone better, so we will end up with the final applicant. So yeah, so if the best applicant is shown before the cutoff point here, r or r minus 1, depends, the algorithm will not succeed. So and this is this simple. So now to the coding part. So I shall attempt to code this as well as I can. There are obviously some better ways to do it, but I feel like this way is one of the most easiest to understand. Right, so what we are going to do is we're going to start and create a function, define interview. So and we're going to give it three variables. We're going to give it the number of candidates, which is important, candidates, and then we are going to give it a cutoff point, right? So cutoff number, so the r that we talked about earlier, and also we want to run this a certain number of times, right? So what we're going to do is we're going to give it allow the code to run as many times as we want, really. And now we're going to set a variable called wins to 0, and wins, as I said earlier, the number of wins will be incremented every time we pick the best candidate for the job, right? So wins is going to be set to 0, and yeah, I'll just explain it here. A win is achieved every time the best candidate possible is picked by the algorithm, right? And now, so we're going to create a for loop real quickly to see if we're going to really quickly create an if statement to check whether the cutoff number is going to be smaller than the number of candidates, right? Otherwise this is not going to work very well. So if cut off number is greater than the number of candidates, then we can just print error. Really, it doesn't really matter that much right now, and we're gonna return and stop it, right? So this is just to make sure that the code will work. And now we're going to create a for loop just to see just to run the number of games. So for anything in range of the number of tries, so this is going to allow us to run our code a bunch of times, number of try. Then what we're going to do is, so we're going to create this array list, if you like, called hierarchy. I'm not sure, I think this is how you spell it. And we're going to pretty much create this list of 1 to the number of candidates, 1 to n, and this is going to be like our candidates, and from best to worst. No, sorry, from worst to best, pretty much. But it doesn't matter because afterwards we're gonna shuffle it. So we're gonna list, and then so from 1 to number of candidates plus 1, and now what we're gonna do is let's check. Right, and we're gonna print hierarchy, right? And now, just going to really quickly check. So interview, we're going to check if this works for now. So we're going to have 10 candidates, and with a cutoff point of 4, which is lower obviously than 10, and then we're going to try once and then see if this works, right? And this should perfectly work. So 1 to 10, we have our array of candidates and we're good, right? So we do not need this anymore. And now hierarchy is gonna, right, now what we need to do is shuffle this, right, because all the candidates arrive in random order. So we're quickly going to shuffle it. So random dot shuffle, and what we're going to shuffle hierarchy, and I think for this we're going to have to import random, and this should be good, right? And now we're gonna print hierarchy once again, which should give us, in this case, right, the same array obviously but shuffled. So good, and this is perfect actually. All right, so we are actually, I'll just write it here, assume candidate, well actually, number, I assume highest numbered candidate is the best candidate, right? And then lowest numbered candidate is going to be the worst. Don't need to write that. And now we start interviewing, right? So we're going to interview people up until the cutoff number. So interviewed candidates, we're going to create this new array from hierarchy and we're gonna cut it off. So we're gonna take everything up until cut off number -1, right? And now we'll just check that this indeed works. So print interviewed candidates, and we are still gonna need print hierarchy, right? So just to check. Now we're going to see, since we put 4, we're going to only take the first 3 candidates, and we indeed have an array with the first 3 numbers. Perfect. And we're just going to comment these out for now. And now, so we need to just grab this new variable called m, and we're going to set it as the maximum, so the best candidate of the interviewed candidates, right? So this is going to be pretty easy. All we do is take the max and we're good. And now what we're going to do, as I said before, we're going to just interview the rest of the candidates, and the first candidate that is interviewed that is better than m, we're going to take him or her, right? So we're going to create a second array once again. So rest is equal to hierarchy, obviously same again, but in this case we're going to cut off number up until afterwards, everything afterwards. Print, let me just check if this does work. So let's run this really quickly. 8, 7, 9, 7, 3, 1, 2, 3, 4, 5, 6. Right, we are indeed missing one. So let's just check. Let's just uncomment these and just check which ones we have. Right, so 5, 9, 2, 7. So we're missing a 7. So we're just gonna take one less, and now this should work. Perfect. Right, perfect. Now we got the rest of the candidates, and what we're gonna do now is we're just gonna sift through the list and just pick the first candidate better than him. Right, so we're gonna, for this, what we are gonna do is first we're gonna set our chosen candidate equal to rest. So we'll set him to anything. We'll set him to the last person, because then what this allows us to do is we can simply sift through the list, and then if we don't find such a candidate, then we already have the last one. Otherwise, if we find a better candidate, then we shall pick that one. So So this one is just going to be picking the last candidate in the event no other candidate is picked, right? Is picked, right? And yeah, so this is what we're going to do. Now we're going to create our for loop. So for might as well call them, let's call them number in rest, right? And we're going to check if, so if number is greater than m, then we're going to set chosen candidate equal to this number, and then we're going to break, and then else we don't really need to write else, so we're good. And yeah, I honestly think this is it. So for number in rest, I'm going to go through every number in the rest of the rest array, and then if this number is greater than them, we're going to choose them, otherwise we're going to pick the last number. And now we just need to check that a condition to check when we actually have a win, so when we actually pick the highest number in the list. So if chosen candidate is indeed equal to, we can just call it number of candidates. I mean, it's not bother here with too many intricacies. So with the highest element in the list, then what we're going to do, we're going to increment win plus equals 1. Let's get rid of the spaces. And right, and we should be good. So now, last thing before we run the code, we're just gonna set up probability. So this needs to be in line with the for loop, yeah, because this is out. So we're gonna set probability. So new variable probability is equal to, so it's gonna be equal to the number of wins, yeah, wins. Wins divided by the number of games we've played, which is called num tries, and obviously times 100 to get the probability, and we want to print that out. So print the probability of a win with this R is with actually let's set it as with cutoff number here as R is space, and here we're just going to input probability, comma, another one, let's just make it pretty, %, and we're good. Right, and now if we run this, we should be all right. Right, so with 4 as R, right, so with 0%, so right now we can see that in this case we haven't 10 was in like at the start of the array. So as I said before, since he was the first candidate, then we picked the 2 and we didn't win, right? So this one, yeah, the probability is quite low. And so what we're going to do, we're going to increase the number of games. We're going to increase them to 100 for now, see if that works at all. So still 10 applicants, and see already, so 42%. Gonna 42% again. We're just gonna get rid of all those prints just to make it cleaner. Print rest, print interviewed candidates. This should be all right now. Let's see. Right, 33%, and then 43%. So what if we want even more fun? We can add 10,000 people and change our R value. Well, why not? And more candidates, right? Having more candidates, and then we'll see if this will run indeed. That this does indeed go to the follow the 37% rule. Right, no, possibly not here, but anyways, with 10 candidates, let's keep 10 candidates. Right, actually this was my bad, because when I increased the number of candidates, I should of course I should have changed the R value, because otherwise it's completely stupid. Right, here we actually are getting close to 37%, right? And yeah, 38.9, 39.46, right? So you can see that indeed with this well-picked R value that I shall explain in the next video, we do get a pretty good percentage of actual good picks, actually, which is actually really impressive when you think about it, since you don't know anything about the candidates that you're going to get. So if you, a third of the time, you can just get pick the best candidate from a random array of candidates, it's really rather impressive. Right, so thank you very much for watching this video. I hope you found it interesting. I shall attempt in future videos to properly explain this the mathematics behind, and explain where the R values come from and how to optimize them. And yeah, so actually just to let you know, like the optimal R value is 10 divided by E, where E is 2.7, well, the natural number E. And yeah, so I shall explain this in another video. Thank you very much for listening, and if you have any questions, drop them in the comments below. Otherwise, thank you very much for listening, and I shall see you in the next video. Bye bye.